a screen share. All right, so let's go through this pretty quickly. Most of it was really, really simple because all you had to do was name your domain and range and then state whether or not it was a what? A function. A function. So remember, when it's like these first few, and you had just ordered pairs, or you had a table, or you had a mapping, or even the one that had a graph, put your phone away. You had a graph that had, the points. Those were what we call discrete. And when we have discrete values or discrete relations, what is it that we look at to see whether or not it's a function? We make sure that what doesn't happen? X cannot repeat. So if X doesn't repeat, it's a function. If X does repeat, though, not a function. And then, of course, as we move further along, when it was a continuous function, so it didn't just have points, but it was a continuous function, we didn't look at whether X repeated. We did this thing called a what? A vertical line test. What we did was we took this vertical line, we scrolled it over that x-axis, and if I ever hit more than 1 point at a time, that was the indication that it was not a function. Okay? If I ever hit more than 1 point, not a function. So we use both methods to determine whether something was or was not a function. So if you look at number 1, it was not a function because the only value of x we had was 1. Or, I'm sorry, negative 1. Negative 1 cannot give you all these different values of y and still be a function. So it's no. Number 3 was a function because if you look at this mapping, every x value only has one thing that it's pointing to. So therefore, absolutely a function. Hey, you're going to put that on my desk now for the rest of class because you flipped it over and now you're trying to cover it up with the paper. No, put it on my desk. I make it really easy for you guys. Now, any questions with 1 and 3? Let's scroll over to number 2 and 4. Both of these are functions. You had one that was just a group of ordered pairs. Number 4, you had one that was a table. No x repeated. Because no x repeated, these were both functions. Okay? Anybody miss the domain or the range? Remember, you didn't have to put them in order, but I always do, and plus, all of them were kind of in order. At least the domain they were in order anyways. All right, moving on. Number 5. Number 5 was the one that I was talking about earlier, that they're still discrete because they're just ordered pairs, but you put them on a coordinate plane, and you can either choose to look at the ordered pairs, or you can still do that vertical line test. And if I do this vertical line test, do I ever hit 2 ordered pairs at the same time? No, then this one is a function. Now, picking the x's and the y's may have been a little harder for you guys on this one. So the x's were -5, -2, 1, and 2. And the y's were -4, 0, and 3. 3 was twice, but again, it's okay for y to be twice, right? X can't be twice. Questions about number 5? Moving on to number 6 then. Number 6 was the first one on the homework assignment that was a continuous one. Now, it wasn't continuous forever, right? But it was continuous in that I can't name all the ordered pairs that are on this graph. Can't do it. There's too many of them. Because when you have connected lines, all of those points on that line would be ordered pairs. So we use intervals instead. So for domain, we said, hey, what's the furthest my x value can be to the left? And that was -3. And then we went, what's the furthest it can be on my right? Well, that's +3. So my domain was from -3 to +3. Okay? For range, we did y. We looked at the lowest value it could be on the y-axis. And then we went to the highest value it could have been on the y-axis. And we named that from -4 up to 2. So -4 to +2. course, number 6 failed the vertical line test miserably, didn't it? I mean, almost every point that you would go across there, you're hitting 2 points. So absolutely not a function. Questions about number 6? All right, here's number 7. On the x-axis, you can clearly see that the furthest point to the left is right here at -4. And this thing goes off to the right forever. So that's 4 to infinity. I'm sorry, my bad. -4 to infinity.
Yeah.
Okay? Sorry. I make mistakes too sometimes. And then, of course, the one that I saw people struggle with the most was the range for this problem. Remember, range is all about what? Y. Does this graph ever come below this y value right here? What is that y value? 0. But then it goes up forever. Now, maybe just gradually, but it's still going to go up and to the right forever. You with me? So that's why my range is from 0 and up to positive infinity. Okay? Does that make sense? It's not too bad, right? All right, last one, number 8. Number 8, have y'all ever seen this little symbol before? This double R?
No.
You haven't?
No.
That means all real numbers. It's just a fast way of writing all real numbers. I kind of like to picture it as the LL in all with an R. All real numbers. Maybe that's dumb, but that's how I remember it. But all real numbers as an interval is negative infinity to positive infinity. So that's what my domain was. This thing never stops going to the left. It never stops going to the right. Now, there were a couple of questions about whether or not these arrows right here indicate that this thing's going to keep going up forever. But I think what we should have done, and what I did, was I just assumed it was going to keep doing this little number. It was just going to keep going up and down, up and down, up and down. So, with that being the case, it never got below what y value right here? -1. And it never got above what y value here? So my range was from -1 to 3. Okay? And this one also definitely passes the vertical line test. So it is a function. Questions? Anybody? Okay, what we're doing today is still about functions. And it's not that hard. I'm going to try to give you guys about 10 minutes left in class to get started on your homework. You should have about 10 minutes, which will be good because you definitely need your calculator a little bit. So if you didn't grab a calculator, go ahead and grab one. Chase, today just grab any one that's up there, but I'll assign you a number at some point, okay? That way you have one that every time you come in, that's the one you grab. There's been some people moving in and out of the class, so soon I'll give you one, and that will be your permanent calculator when you come into class, okay? So we're talking about 2 main things today. Okay, yesterday, our 2 main things were, is something a function or not a function, right? And we know what that is now. We know what that looks like now. And we also talked about how we name our domain, what x could equal, and our range, what y can equal. Today, we're talking about 2 other concepts. The first one is increasing, decreasing, or constant intervals. And then also, we're talking about minimum and maximums. So all pretty simple, okay? Now, first thing, before we get started, I want you guys to remember that when we look at a graph, when we read a graph, we read it just like we read a book. How do you read a book?
From left to right.
We read a graph the same way. We read a graph from left to right. So when I look at this graph over here to the right, and I think about it from the perspective of, hey, where is it increasing, where is it decreasing, where is it staying constant? I'm looking at that from the perspective of from left to right. So right off the bat, as I move from left to right, what is my graph doing? It's going down, isn't it? As we move from left to right, it immediately is going down. And going down means it's decreasing. Okay? Now, remember what I said about it's all about what a graph is doing from left to right? Guys, on a coordinate plane, what axis is left to right? The x-axis. And because we look at a graph from left to right, and the x-axis is left to right, when we name increasing, decreasing, and constant intervals, our focus is the x value. Let me explain. Y'all see, because I know y'all done coordinates before, ordered pairs, right? Y'all see this point right here? What is that point? It's -2, 4, isn't it? But when I name the increasing or decreasing or constant interval, I'm not looking at the whole ordered pair. What is my focus? The x. The x. So when I start talking about, hey, where does this graph start decreasing? I don't say, well, it starts decreasing from -2 to 4. I say it starts decreasing from what x value? -2. Y'all understand that? And as I continue moving across the graph from left to right, where does it start stop decreasing? At 0. At the x value 0. So therefore, you would say it is decreasing on the interval -2 to 0. Now let me explain what y'all just wrote. Why we wrote parentheses. Y'all remember yesterday when we were doing the domain and range? If I did something like -2, what did I use as the what do you call it? The grouping symbol. I used a bracket. Remember, because I told you that it got to that value. And because it includes that value, we used a bracket. When I use intervals, I use parentheses, and here's why. Is it decreasing at -2? No. It's decreasing as it leaves -2. You understand? And because it's decreasing as it leaves -2, that's why we use a parenthesis. Is it decreasing at 0? No, it's decreasing as it approaches 0. You understand? So that's why we use parentheses when it comes to intervals of increasing, decreasing, or constant. Okay? So, what does it do? Right as it stops decreasing, it then starts what? It flattens out, doesn't it? It remains what we call constant. So it remained constant from 0 until it gets to this point right here, which is what x value? 2. So what interval would we say it's constant on? From 0 to 2. Notice how we always do small to big. We always do small to big. And then lastly, as I'm reading this thing from left to right, what's it doing at the end? It's increasing. It's going back up. It's going back up from 2 to what x value? +4. So we would say it's increasing on the interval 2 to 4. Does that make sense? All right, so y'all ready to practice some of these on our own? All right, look at letter A with me. What's this thing doing right off the bat? It's a constant. So I'm just going to use a C, okay? Y'all know what C means, constant. What x value is it beginning at?
-5.
-5. So it's remaining constant as it leaves -5 all the way until it gets right here at what x value? 2. Look, guys, this thing is remaining constant all throughout this region. And that's why we use an interval to represent that. You follow? Okay, now what does it do? As it leaves that constant area, it starts doing what? It starts decreasing. It's going down. So I'm going to use a D for decreasing. As it leaves 2, and it gets right here to this x value, what? 3. So it's decreasing, if I shaded it, in this little bitty region right there, from 2 to 3. You understand that? We're naming it as we go across the x-axis. We don't care about the y values when we name the increasing, decreasing, and constant intervals. We care about x. You with me? Okay, so what's it doing from that point? It's increasing again. It's increasing, not again, for the first time, my fault. It's increasing as it leaves 3. And how long will it increase, guys? 7? No, that's a what? That's an arrow. So how long will it keep going up? Forever. So it's going to increase from 3 to what? Infinity. It's going to keep on going in this direction for as long as you can imagine. Okay? It's just going to keep going forever. Okay? Questions? That's how we name our increasing, decreasing, and constant intervals. Let's do a couple more of them. Again, we're looking at this across from left to right, aren't we? So look at it from left to right. You're reading this graph. What's it doing right off the bat? Huh? You sure? Now, a lot of times, look, this is a common mistake. We look at this, and that arrow looks like it's going down. But down is what axis?
Y.
We're not thinking about y, are we? We're thinking about x. So it's coming from the left, but what's it doing as we move to the right? It's going up. It's increasing. So this thing right off the bat is increasing. Where did that arrow come from, y'all? From the left. Where did that arrow come from the left? It came from negative infinity. Look, it kept going left forever. Okay? And it goes up and up and up until it gets right here to this x value. So this is the area where this thing is increasing. Right here. So where is that to? -3. And then what does it start doing? It starts decreasing as it leaves -3. And it decreases, it goes down and down and down until it gets right here to this x value, which is what? +1. So it's decreasing from -3 to +1 throughout this entire region, right here. As we move from left to right, it's going down. That's -3 to +1. And then what does it start doing again? So I'm going to go back up here to the increasing area. You don't have to make a new category of increasing. But it increased as it left 1, and it went all the way to right here, which is what x value?
4.
So it's increasing from 1 to 4. And then what's the last thing it did? It remained constant from that same value 4 to infinity. Okay? And that's it. That's how you do this. Now y'all choose. Y'all want me to do C or D? D? Let's do D. So I'm looking at this. How am I reading it, y'all? From
the x-axis.
I'm looking across the x-axis from left to right. So guys, as I look at this from left to right, what's it doing? It's decreasing. Look, it's falling. It's falling from left to right. So it's immediately decreasing. Now look, from the left, where did it start decreasing? Negative infinity. Now, again, a lot of people want to look at this and they see this arrow pointing up. Is that arrow pointing up?
Yeah.
So they want to think positive infinity. But what is up, y'all? Y. Y is up. Not only is this thing going up, but it's also going what? It's going,
Down.
no, that arrow. It's pointing up, but also to the left. Left is X. And where is left forever?
Infinity.
What kind of
Negative
infinity?
infinity.
Negative infinity. That's where it's coming from. And this thing is decreasing, and it's decreasing, and it's decreasing until it gets right here at what X value?
-3.
Are you with me?
Yes.
All through this region, this thing is decreasing. But then it starts doing what?
Increase.
It starts going back up. It's increasing. It's increasing and increasing and increasing until it gets right here to this X value, which is what?
0.
So from -3 to 0, this thing is increasing. Then what does it do again? It decreases again until it gets right here at what X value? So from all of this space right here, 0 to 2, it's decreasing again from 0 to 2. And then what's the last thing it's doing? It starts doing what from here?
Increase.
It starts going up, and it goes up, and it goes up, and it goes right, and it goes right, and it goes right, forever. So from +2 to where?
Infinity.
Positive infinity. Because it just keeps on going. Which direction? Right. Okay? And that's how you name increasing, decreasing, and constant intervals as you look from left to right. Any questions? Okay, get your calculators out, and we're going to flip over to the back. Alex, did you write those down? There's a difference in not being asleep and actually doing what we're doing. Did you write any of those down? Did you write any of those down? Then did you do what you were supposed to be doing as a student? The answer to that question is no. Good job. All right, now, what's that? Okay, that's a good choice to say no. All right, so the next thing that we're talking about is this concept of relative maximums and minimums. Now, the only reason they're called relative is this. Sometimes we're dealing with figures like a cubic function. A cubic function does this. It like starts going up maybe. It gets to a certain point though, it starts going down. But then it gets to a certain point, it starts going up. So here's my question. Does this have a true maximum? No, because what's this thing going to do forever? It's going to go up forever. So it doesn't have a true maximum because it's going to go up forever. Does this have a true minimum? No, because it's going to go down forever too. So when these don't have true maxes and true minimums, they go ahead and just call them relative maximum and minimums. So what a relative maximum or a relative minimum is, it's when your graph has what we call a turning point. It's when it stops going one direction, it starts going the other. So for example, this sucker's going up, 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 right? But then all of a sudden right here, it turns and it starts going what? That's a turning point. That's what we would call a max. It's not really the max. It's a relative max. Okay? It can't be the real max because this thing keeps going up forever. But it's a max. Okay? Now, it's going down now, down, 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 but then it gets to a point where it stops and it starts going back up. What's that called? That's called a minimum. So the next thing we're doing is we're finding these max and mins. And we're going to do it using our calculator, okay? So all the key presses that you would need to make in a calculator to find these minimum and maximums are all listed right here, okay? And it looks like it's quite a process, but it's actually really quite fast. It doesn't take as long as you might think. So we're going to do 2 examples real quick, and then I'm going to use the first example to connect to what we just talked about, and then I'm going to give you guys your assignment. Okay, you'll have about hopefully 10 minutes to kind of work through a couple of these before. So get your calculator and remind me, Adam, what do I like you guys to do right when you get your calculator? Yeah, just reset them. Second plus 7, 1, 2. It's always up on my board in case you forget. On that top right corner, y'all see it? It's always going to stay there. And again, somebody had this calculator before you, and they may have screwed something up. It's best just to reset it, okay? Now, here we go. We're going to follow the instructions. We're going to go to y equals. We're going to graph the function. So I'm going to type in to y equals x squared minus 6x. Okay? Now, I'm going to graph it. And this is what we call a parabola. This is a graph of a quadratic, a parabola. Y'all have heard that before, haven't you? Parabolas. This is a parabola. A parabola actually has what we would call a true what? Here. That's a true minimum, isn't it? This graph never turns back down and goes below this point. That's a minimum. So we're going to find, using our calculator, we're going to find that minimum. Ready? You're going to go second. Everybody do these key presses with me. Second, trace. Up top. Y'all see it? It says calc above it. Second, trace. We definitely want to do a number 3, a minimum. The next thing is, y'all see the minimum down here where my cursor is? I want to go just to the left of it with my cursor. So I'm going to bring my cursor down until I'm just to the left of it. So that looks pretty good, doesn't it? And we do a left bound. So you push enter. Then what does your calculator say? So guess what we do? We go just to the right of that minimum. So you scroll until you see it come back up. There it is. I see it. It's coming back up. There's the right bound. Push enter. And then it says guess. You're going to push enter one more time, and you're going to write your answer as what we call a ordered pair. What is the minimum for this function? What is the minimum for this function? What's the x value? Guys, what do you think 2.9999999 would be? Nah, let's go ahead and round that to a 3. Because if I rounded to 2 decimals, wouldn't that definitely round to a 3? And then what does that y value say? Can y'all see it? It says -9. So my minimum for this quadratic is 3, -9. Now, let's make a connection. As this graph moves from left to right, what's it doing right off the bat? It's decreasing. Vaughn, where did it start decreasing? Negative infinity. Now here's the key. Y'all see my minimum, right? 3, -9. As we move across the x-axis, where does this thing stop decreasing? What point do I care about? The x or the y?
X.
I care about the x. So this thing is decreasing from negative infinity to where? Not negative 3. 3.
I didn't say -3, I said 3.
Oh, my fault. I misheard. And then what does it start doing as it leaves the x value of 3? It starts increasing, and it will increase from 3 to where?
Infinity.
So, y'all didn't have to do that. That's not what the question asked here. But your minimum is 3, -9. It was decreasing from negative infinity to 3, and it increased from 3 to positive infinity. The key thing I want to make sure you guys understand is this. When it comes to your increasing and decreasing intervals, your focus is the x value of your minimum and maximums. Look, it's in both of these. It was the key to where it stopped doing one thing from left to right and started doing the other. So never use the y value, always focus on the what? Can y'all remember that? It makes it really easy if you can remember that. Because when you find those ordered pairs, which I know you guys can do, it's not a hard thing to do, because you get to use your calculator. Your focus is the x value of those minimum and maximums. Okay? So try to remember that. And then let's do B, and listen, let's just do the min and maxes. We won't worry about the increasing and decreasing intervals. So here we go. Y equals, clear that out. Now we're doing negative x. Y'all know how to do cubed? Huh? You do the caret, and then you fill it in with a 3. Very good. And then you scroll to the right, and you do minus 5 x squared plus 12. Now I'm going to graph this, and what does this have? It has a what? Here. It's got a min, and it's got a what here? All right, so let's find this minimum first. So let me write on my piece of paper, minimum. And we're finding an ordered pair, right? So where do I go? Y'all help me out. Second, trace. Number 3, minimum. We scroll over, and again, you see where my cursor is? I'm going to scroll over until I'm to the left of this point. So let's scroll over until it comes back up a little bit. There we go. Now we're to the left of that minimum. Push enter. Now I'm going to go to the right of that minimum. Push enter. I'm going to push enter one more time, and its best guesstimate for me is what x value? I like to do 2 decimals, so I'm going to do negative 3.33. And what's the y value? Negative 6.52 right here. So there's my minimum. Okay, here's my minimum. Negative 3.33 and negative 6.52. Okay, next. And this is the one that I really need you all to see. Second trace. This time we're going to find a number 4, a maximum. So let's scroll up, and we're going to go just to the left of that max. I can see my cursor right there to the left of it. Push enter. Now let's scroll, let it come back down. There it is. Push enter. Push enter one more time. And there's a variety of answers that you're going to get here. But all of them are going to have one thing in common. Notice my x, 1.94. Look, here's 1.94, isn't it? Does that max look like it's up there? No, it looks like it's way over here. Does anybody else have anything besides 1.9? I have 1.37. You have 1.37? What do you have? That's good. That's what it is. What else did anybody else get? Anybody else get anything way different than 1.93 or 1.37? Look, here's the key that I promise you Riley's has and mine. Y'all see this E right here? When this calculator does this, that E is for scientific notation. Y'all remember scientific notation? 1.93 times 10 to the negative 6 is what this means. So that means my decimal actually moves 6 to the left. If I move my decimal 6 to the left, this value is actually 0.000001937. Guys, if this is really 0.000001937, what's the actual value? 0. What Adam got when he did his. Now, I don't know why his gave him 0 and mine gave me 1.9377 times 10 to the negative 6. But either way, when you see this e to the negative something, it means that your value there is 0. Please remember that. Your calculator does that all too often. Now, what's the y value? 12. So, my minimum is negative 3.33, negative 6.52, and my maximum is 0.12. Now, we're not going to do this on this problem, but if I were going to do my increasing and decreasing intervals, what of those values would be significant? The x, negative 3.33 and 0. That would be my focus when I wrote my increasing and decreasing intervals. But we're not going to do that. Instead, I'm going to go ahead and give you your homework. And I'm going to change it. It's not the whole worksheet, so don't stress out when you see it. I'm going to give you 8 problems. Okay? Just 8. Only 3 would need a calculator. So I'm going to encourage you guys to use your calculator on those first. So let me pass these out, and then I'll tell you which ones you do. Oops, sorry. Grab. You're welcome. All right. Once those get over to Whitney, let me tell you the ones I want you to do. Y'all ready? I want you to do numbers 1. You want to circle them? 1, 2, 3, and 6. 1, 2, 3, 6. And that's your increasing and decreasing and constant. On the back side, I want you to try number 7. Everybody's will probably look different because of what you're doing on 7. And then I want you to do 9, 11, 13. I would encourage you to go ahead and do 9, 11, 13 because those are your minimum and maximums, and you can use your graphic calculator on those right now. And you can probably go ahead and knock those out before class is over. So that's it. 1, 2, 3, 6, 7, 9, 11, 13. Okay? 8 problems. And again, if you knock 9, 11, and 13 out with your calculators, the rest of your homework can be done without it. Okay? What time do we get out of here? Oh, shoot. I did bad with y'all. I'm sorry.
Get out of here.
Always us.
I'm sorry. I don't know why.